Yes, hello students. Now I will explain one more concept that is called single slit diffraction. So in the last class we have studied that diffraction and types of diffraction. In that two types of diffractions are there, Fresnel diffraction and Fraunhofer diffraction. So for your syllabus you have Fraunhofer type diffraction. So today I will explain that one. Let us consider a source of light. This is the source of light, and from this source of light a diverging beam of light ray will emit, and these diverging beam of light rays will incident on this convex lens. That means you have to consider that, so this source of light is exactly placed at focus of this lens. Then after refraction, you know that these light rays become parallel to principal axis, right? And so now I will place a slit here, a aperture, on the width of the aperture let us take it as A. Then these light rays will travel in this direction in a straight path. In this path, and this is one set of light rays, or let us take one beam of light rays, and I will consider another beam of light ray also. This is second beam of light rays. So this second beam of light rays is making an angle theta with this first beam of light rays, or let us take at x-axis, it is making some angle theta, and this theta is called as angle of diffraction or diffracting angles. Then in this path let us place one more lens having larger aperture and larger focal length. Then definitely these light rays will incident on this lens, first set of light rays, that is parallel to each other and parallel to principal axis, that is the first set of light rays, and second set of light rays are parallel to each other, but it's making some angle with angle theta with, you can consider with parallel this one with principal axis. Then after these light rays are parallel to each other and parallel to principal axis, after refraction you know that definitely these light rays will meet at focus. These are also parallel, second set, but not parallel to principal axis, that will meet at focal plane. That means exactly at a distance of focus from this optic center we have placed a screen. So this screen is placed at focus of this lens. Then these light rays will travel, and after refraction these will meet at the focus. This is one more set of light rays. These will travel and they will converge at focal plane. So about this you have know in ray optics also. Then see here, if you consider a source and these are the ray of light, means if you draw these becomes wavefront. These spherical wavefront incident on convex lens. After refraction these wavefront become a plane wavefront. let us take xy. Xy is the plane wavefront. This wavefront incidenting on this slit. This portion is blocked by this opaque medium substance, and this portion is also blocked by opaque medium or substance. Then this remaining portion is available here. And according to Huygens principle, you can consider every point on the wavefront as a fresh source or secondary source. So let us consider the slit here. This is let us take A point and B point. That means between this slit there is a wavefront, and every point on the wavefront is a new source. That means every source will send secondary wavelets like this. In this secondary wavelets, you can draw a perpendicular line, any number of perpendicular line. So from A point, these are the perpendicular lines. These perpendicular lines represents ray of light. From B point also I am drawing perpendicular lines. Then you can observe, let us take this is 1 and this is also 1, and this is 2, this is 1 dash, and this is also, let us take it as 2 dash. Observe carefully, 1 and 1 dash are parallel to each other, coming from two different points, two different source, right? Then here 2 and 2 dash also parallel to each other. Again, one is coming from A point, another coming from B point. In the similar way, the wavefront is here. Every point is a new source, and from A point and B point, I have selected two sets of ray of light. That is 1 and 1 dash. 1 and 1 dash making angle theta with principal axis, and they are superimposing at point P. This is one set of light ray I have chosen, and another set, that is 2 and 2 dash. The light rays are that means traveling parallel to principal axis and parallel to each other. This is the second set of light rays. And for this second set of this light rays, there is no path difference. How much distance this light ray will travel, this light ray will also travel same path. Hence at this point, at the center of the screen, you will observe bright fringe or central maxima. But at P point, you can observe that this, let us take it as A, and this let us take it as B. A to P distance, B to P distance are different. There is a path difference. Due to the path difference, here we can obtain the conditions for bright and dark fringes. At that point, it obeys bright fringe conditions. Bright fringe will form, or it forms a dark fringe. And also I said this is central maxima. At the center again bright fringe you will observe, that is central maxima. Next you will observe a dark fringe. The dark fringe is called as first secondary minima. First secondary, or you can say subsidiary minima. In interference, bright and dark only you are using, right? But here you have to use the sentence like first secondary or subsidiary minima. After minima, again maxima. But here what you have to use the sentence means first secondary or subsidiary maxima. Secondary and subsidiary meaning is same. Below also same. First secondary minima. Next first secondary maxima, and next second secondary minima, second secondary maxima. Similarly, nth secondary minima, nth secondary maxima. In this way, we will use the sentences for bright and dark fringes. Next, I hope you understood this one. These angles are called angle of diffraction or diffracting angle. And once again I will explain, listen. A source is placed at the focus of this lens, and this lens is used to make the light rays, to get parallel beam of light rays. Okay, and here these light rays are incidenting on the slit. You can consider wavefront also. That wavefront is present in between A and B point in this width. Then I have selected two sets of light rays. One is in this direction, they are superimposing at P. Another one is parallel to principal axis in this direction. Then in the path of these light rays, one more lens, a larger convex, a larger focal length and a larger aperture, a convex lens is placed. Then these light rays will incident. These light rays will converge at focus. These light rays will converge on focal plane. Exactly at the focus, we have kept a screen. Then here no path difference, central maxima. Here we obtain conditions for constructive and destructive superposition. That means conditions for maximas and minimas. And I said here how the source and screen is in Fraunhofer type diffraction. You know that the distance between source and screen is infinite, effectively infinite. That means, so for this screen, these are the parallel lights are coming, means for this lens, right, for this lens, where is the object? Definitely the object is at infinite. This object, this is the object for this lens. Okay, this, yes, I have written right, source, it is the object for first lens. But for the second lens, it is not the object. For the second lens, the object is at infinity. Why? Because the incident light rays are parallel. So I will rub this diagram, and next I will get the conditions for minimas and maximas. So first one, write down minima, conditions for minimas. Conditions for minimas, for that is dark fringe. I will write first here, first, secondary or subsidiary minima. First, secondary or subsidiary minima. That means for this, let us consider a slit. This slit width is, let us take it as this point as A and this point B, right? That slit width, let us take it as A. And also in the previous diagram, I forgot to explain. So listen, this is the one set of light rays. This is one set of light rays parallel to each other and parallel to principal axis, and this is another set of light rays, isn't it? Parallel to each other but making some angle theta here. Then what is the path difference? These two light rays will superimpose at point P. Means what is the path difference? Means from A point you have to draw a normal. By drawing normal, this will become the path difference. Let us take this point as N. Bn is nothing but path difference. And in the diagram, observe carefully, the width of the slit is small a. This angle is theta. This angle become 90 minus theta. This is perpendicular 90 degree. Then this angle you will get as theta. And if you apply sin theta for this triangle ABN, you will get Bn value as A sin theta. This Bn is nothing but path difference. Path difference as A sin theta. Similarly, in interference, we obtain path difference as D sin theta, right? Here the path difference is A sin theta. Then we have taken a slit. Next, to obtain the conditions for minimas means what you have to do? You have to use logic. What is the logic means? You have to divide slits into two equal parts. Doing this only we can understand the condition for minima. Divide slit into two equal parts. So this is one slit. These are the light rays. These are superimposing at point P. Here we have to divide the slit into two equal parts means, so we have to consider like this. This is one part and so this is one part and this is the second part, dividing slit into two equal parts. So this point is A, this point we have taken as B, let us take this point as C, and so this is the path difference, that is B to N. So divide slit into two equal parts. Next what we have to consider? We have to consider the path difference A sin theta, that is equals to lambda. So this is our consideration. We have to treat the path difference as lambda and we have to divide slit into two equal parts. By doing like that, what happens means, this is path difference, right? This path difference is lambda. So this is, we have divided equally into two parts, isn't it? Then this path difference will become lambda by 2. That means this is first upper half, this is second, this is lower half. Okay, this is upper half and now this becomes lower half. Between A point and C point, what is the path difference? Lambda by 2. Between C point and B point, what is the path difference now? Lambda by 2. Like that, consider an 100 points are there in between A and B. Between A and B, 100 points. So C points become 51. Let us take A point as 1. C is midpoint, right? 1, 51 and this is 100. This point is 100. Between 1 to 100 we have divided into two equal parts. So that midpoint becomes 51. Then you can able to see what is the path difference between 1 and 51. 1 and 51, the path difference is lambda by 2. Similarly, this one, 2 and 52. 2 and 52 path difference is also lambda by 2. Like that, here this one 50 and 100. 50 and 100 path difference is also becomes lambda by 2. That means you will get a point in upper half, corresponding point you will get in lower half. Okay, one point in upper half, there will be a corresponding point in lower half. Between these 2 points, the path difference become lambda by 2. And we have studied constructive conditions and destructive conditions. Lambda by 2 path difference means definitely a dark fringe will form, isn't it? That means for every point between A and B also, you can observe that path difference between A and C also you can observe that the path difference is lambda by 2. Like that, any point you consider in upper half, you will get a corresponding point in lower half. Between them the path difference become lambda by 2. These two waves will go and meet at P having the path difference lambda by 2. Definitely there will be a dark fringe. That means for dark fringe, A sin theta you have to consider as lambda, or let us take it as A sin theta 1. This is for what? First secondary or subsidiary minima. Next, to get the condition for secondary or subsidiary minima means, what logic you have to apply? You have to divide slit into split into 4 equal parts. So this one also I will explain, listen. This is a slit, single slit means this is one part, this is second part, this is third part, and this is fourth part. Like that you have to divide the slit into 4 equal parts. Then after we have to consider path difference as 2 lambda. Next, path difference become 2 lambda means this is path difference, right? A sin theta. This path difference you have to consider as 2 lambda. Then you will get 1 point here, 1 point here, 1 point here means what is the path difference between A and this point? That will become 3 lambda by 2. This will become lambda by 2. And sorry, this will become lambda and this will become lambda by 2, isn't it? So you can consider a point in first upper of, so corresponding point you will get in first lower of, between them the path difference is lambda by 2, and one point you can consider in upper of, second upper of, then a corresponding point you will get in second lower of, between them also the path difference becomes lambda by 2. So path difference between two waves is lambda by 2. They are superimposing means definitely at that point a dark fringe will form. Like that completely this first part will meet all the waves. Between the waves the path difference become lambda by 2, meet at point P. So first wave completely forms dark fringe. Similarly the second part also same. The second part also meet at point P, between one point in upper half, corresponding point in lower half, the path difference lambda by 2 means like that this complete set also forms a dark band at point P. So this is the condition for secondary minima. A sin theta 1 is equals to, we have to consider 2 lambda. And what is the condition for, sorry, just you have to write like this only, right? Secondary minima. And next, what is the condition for nth secondary minima? Nth secondary minima means you have to consider the equation that is for an sin theta n. This should be equals to n lambda. This we are discussing for dark fringes, minimas, in interference. N lambda is for bright fringe. In diffraction, n lambda is for dark fringe. I hope you understood the conditions for minima. Next, I will explain the conditions for maxima. What are the conditions for maxima? So we have to consider a slit, this point A and this point B. Now we have to divide slit into how many parts? 3 equal parts. You know that central, always bright fringe will form, central maxima. 3 equal parts. That means in this way 1, 2, 3 equal parts. Next, path difference A sin theta 1 dash, let us say, for bright fringe, right, should be equals to, in dark fringe first you have taken lambda, in bright fringe first you have to take as 3 lambda by 2. This is logic, like this we have to apply, and we have to understand the conditions for maxima, dividing slit into 3 equal parts and considering path difference as 3 lambda by 2. Then here this becomes, between this line and this line, what is the path difference? That will become lambda. So here lambda by 2. Then consider a point in upper half. corresponding point you will get in lower half. Between these 2 points, path difference lambda by 2, they superimpose dark fringe. Like that, one more point, for that another point will be formed here. Between them lambda by 2 superimpose. Then complete set forms dark fringe there at point P. But see one more part. For this part, if you consider one point here, no, there is no corresponding point in lower half, right? For this point there is a pair. For this point there is no pair. This is single. So it will travel and they meet at point B. So there is no corresponding point. Hence, due to this part, we will get some brightness there. Not completely bright we will not see. Why? Because this part forming dark fringe, only a small portion you are observing, right? This will form a bright fringe, so we will see some brightness, right? So we will give the name called first secondary or subsidiary minima. Central maxima, brightness more. First secondary maxima, brightness decreases. But in interference you won't observe like that. All bright fringe intensity is same, all dark fringe intensity is 0. But in diffraction, all dark fringe intensity is 0, but all bright fringe intensity is not same. Central maxima intensity is more, brightness is more. Then first secondary minima, intensity, brightness decreases. This is the condition for first secondary minima, first secondary maxima. A sin theta 1 is equals to 3 lambda by 2. Next, what you have to consider? That is the second secondary maxima. Again, a slit. This point is A, this point is B. Then 3 equal parts. Next, you have to consider 5 equal parts. Then path difference, you have to consider 5 lambda by 2. So here you have to consider like this: 1, 2, 3, 4, 5 equal parts. Then the path difference you have to consider 5 lambda by 2. This is 5 lambda by 2 means this is 2 lambda. This is 3 lambda by 2. This is lambda by 2. This becomes lambda by 2, isn't it? Then a point in upper half, corresponding point in lower half. This complete set, the path difference between lambda by 2, no, this complete set forms dark fringe. Next you see, this complete set also will form dark fringe. One point is here, corresponding point you will get here. Between them lambda by 2 path difference. They superimpose, forms dark fringe. But you can see there is only one part is remaining. If you consider any point here, there is no corresponding point. This is live at that point. This is not forming a dark fringe. Hence, due to this portion only we are getting some brightness. Here still brightness is decreased, but there is some brightness. Hence, we will say this is a secondary maxima. For second secondary maxima, A sin theta dash, that is equals to 5 lambda by 2. And next, similarly for nth secondary maxima formula, A sin theta dash n is equals to, you have to consider 2n plus 1 lambda by 2. This is the condition. So in interference you can consider 2n minus 1 lambda by 2 also path difference, or 2n plus 1 lambda by 2 also path difference. Same, that is for dark fringe. But here 2n plus 1 lambda by 2, it is for bright fringe. Like that you have to place the n value as 1, 2, 3. If you place n value 1, 3 lambda by 2, that is for first secondary maxima. 5 lambda by 2 by placing n value 2. Second secondary maxima. In this way, these are the conditions for maxima and the minima in diffraction. And also remember this point, yes, that means for minimas. For minimas, we have taken a sin theta should be equals to n lambda, right? For nth the nth minima. Similarly, for maximas we have taken a sin theta is equals to 2n plus 1 lambda, right? 2n plus 1 lambda by 2, isn't it? That means if this is a screen, here which will form maxima, central maxima. Central maxima, you can able to see the bright fringe, means let us consider this is the intensity distribution curve. So here this is central maxima, here intensity is 0, isn't it? So which will form first secondary minima, not only minima, here you have to use the word first secondary minima. And next this is what? Maxima, that is first secondary maxima, isn't it? Again next intensity becomes 0, minima, like that central maxima intensity brightness more, then first secondary maxima intensity is less, brightness is also less. So this is what? Secondary minima. Here also same, this is first secondary minima, and next this is first secondary maxima. Next year you will get secondary minima. So in this way finally the intensity will decreases. So in interference you will get more number of fringes, but in diffraction you won't get more number of fringes, you will get a few number of fringes, but central maxima intensity is more. So a sin theta is equals to n lambda. So this is a slit, if you consider this is the midpoint of the slit, means so this one, this angle theta represents what? Angular position. Exactly, it is at first secondary minima, right? So for secondary minima, if theta is small, you can use sin theta as theta. For small angles in diffraction it forms a small angles, so theta is equals to, you can consider it as n lambda by a. Remember, for first one means, for first secondary minima n value becomes 1, lambda by a. That means this is first secondary minima, means its angular position become lambda by a. For second secondary minima means its angular position become 2 lambda by a. Next 3 lambda by a, n value you can able to give it as 1, 2, 3, that will tells the angular position of the minimas. And here maximas, again theta is small, then this theta you can consider it as 2n plus 1 lambda by 2a. That means if you consider first secondary maxima, this angular position, that angular position becomes, if you substituting 3 lambda by 2, so 3 lambda by 2a. 3 lambda by 2a is for angular position of first maxima. Like that 5 lambda by 2a is for angular position for second maxima. So remember these points. Yes, I hope you understood these concepts, and in the next class I will explain some points useful for competitive exam. That is about intensity distribution curve, and then angular fringe width, linear fringe width. Next I will enter into the new concept. Thank you.